Okay, this is going to finish off the electric field series. Today, parallel plates, conductors within parallel plates, corona discharge, and how the hell that works with a photocopier. First one we've got is a positive plate at the top here. So we have a positive plate, we have a negative plate. Now think of a positive plate as a series of positive charges all smushed together, really tightly packed, and the negative plate similarly like this. So if you had a positive charge on its own, it would have a field going out, field going out, field going, blah blah blah. Alright, but if you consider this one, it's got a field going up, field going down, and crap, nothing going on either side of here. If we had the negative one, we'd have field, blah blah blah. Okay, so all of these things add together using superposition like in the last video, and some of the bits and pieces they just cancel out. So this one outside here, this one outside here, they tend to cancel out. All of these sideways bits in here, they all cancel out. So remember the last video we had the ones that go kind of like this, you know, upward angles. These two charges are so closely packed together that all of these things end up just coming out parallel. So what we have is perfectly, wow, that's terrible, perfectly uniform field lines out of the positive one into the negative one. And what this means is that a positive test charge will head in that direction. Obviously, it's going to be repelled from the positive, attracted to the negative. Now, if we go to example number 2 here, we've got a positive, a negative plate and a hollow conductor. What happens is that the positive plate up here will attract the negative charges that are free to move inside the conductor or on the surface of the conductor. Doesn't make the conductor charged overall, it just separates the charges within the conductor itself. So a lot of the negative stuff flows to the top to be closer to the positive and away from the negative, which means that there's an overall net positive down the bottom. It doesn't mean that positive charge moved to it, it just means negative charge moved away from it. What that means is that we have bits of this conductor kinda acting like plates itself, and we end up with this weird kind of arrangement. Okay, and what that means is that your positive test charge is going to do some weird stuff when it's inside there. Example number 3 is this corona. So we have a corona that is originally, you know, pretty uniformly charged, you know, stuff spread out pretty evenly, and within, you know, millionths of a second, several millionths of a second, what happens is the negative charges sort of find their way around here to, I don't know, cancel the positives out in a way. I guess there's more positives up here, so lots of the negative charge will actually flow that way. They're applying forces on each other, just like, you know, this example over here, they're applying forces to try and push and pull and whatever. Remember, the positive charges cannot move, it's only the negative ones that can, which means that you end up with an excess of positive charge building up around this sharp point. We've played around with the Van de Graaff generator, and the Van de Graaff is kind of a nice dome shape, so the charge doesn't jump off of that unless you bring something kind of close to it, like the back of your hand, a fluoro tube, the discharge wand, all of those sorts of things. So here what we're going to do is bring over some air particles which are going to kind of act like the discharge wand. What we've got is positive and negative stuff within air molecules, especially water vapor and things like that. So these air particles are, you know, kind of wafting around, and what they tend to do is orient themselves so that the negative charge is close to the positive, because they're easy to sort of flip and spin and whatever. They're just tiny little bits of water vapor, which means that this negative charge here will go bang, jump over, and it'll arc across, and that's the spark that you see. What that means is that poor little guy is now positively charged, so is he, positive charges, these things are now repelled away from the corona shape. And this is how a corona will charge objects. So a corona is effectively just a sharp point. High concentration of charge around that sharp point means it can ionize the air. Ionizing air by stealing electrons. Okay, once it's stolen the electrons, this stuff's positive, gets pushed away. And what we can do is use that inside a photocopier, where we use one of these to charge the drum. So we have a big drum inside a photocopier, have a corona wire like this, the drum is sprayed with charge, these things here actually can carry the charge onto the drum. They hit the drum, which is a semiconductive, a photoconductive, I guess. So it'll conduct when it's got light on it, blah blah blah. So it'll actually, it's a metal coating, but it's not really that conductive unless you sort of kind of trick it into being so, I guess. These air particles will steal electrons from here. The air particles are then not charged, but then the drum is. So this will be the positively charged corona wire, induces a positive charge on the drum. The drum then gets light shone down on the top, which discharges where the light hits, not where the writing on the paper actually is. So you have all these dark spots on the surface of the drum. That picks up toner from the toner hopper, and then underneath we have paper and another whole bunch of corona wires. Now the corona wire down here just happens to carry more charge than the original one, which means that in a tug of war between all these pretty much microscopic little toner particles, paper wins. Paper beats drum. Okay, then the paper's won this tug of war. It's got the toner stuck to it because it's more charged than this was, so it's a bigger attractive force. Remember, force is proportional to charge. There's more charge here than there was here, so it wins. Paper goes through hot rollers, which then melts the toner into the surface of the paper, which was why it comes out all nice and warm, and then it goes past, feeds up through and around some roller things and goes past a whole bunch of brushes before it comes out. These brushes here discharge all the excess charge on it. Okay, and that's how a photocopier drum is charged by a corona wire, and also how the paper is charged by a corona wire. It's this process here, and it's really kind of cool.